Hello, I'm Mr. French. I'm coming to you from my classroom in Mount Pleasant, Utah, and this is topic 3.1, the chain rule, working with some examples of how the chain rule works. So let's look at our first example. Here we have f being the function defined as the tangent of h of x, where h of x is some other function that is differentiable. Differentiable means we can find the derivative. So what is the derivative of f with respect to x? So I am looking, in this case, for f prime of x. By the chain rule, I have to identify my inside and outside functions or operations. My outside operation, the thing outside all the parentheses, is the tangent. So we start with the derivative of the tangent, which is the secant squared. And then we leave our inside alone at this point. So the h of x remains untouched. I'm taking the secant squared of h of x. Then I multiply by the derivative of the inside, or the next layer. So that would be the derivative of h of x, which would be h prime of x. And there's our answer. Secant squared of h of x times h prime of x. Let's look at another one. All right, here in this case, f and g are these functions, 3x to the fifth and the natural log of x plus x. H is going to be the function defined by f of g of x. We're going to create a composite function from f and g. And I want the correct expression for h prime of x. Well, the formula for h prime of x would be the derivative of the outside, f prime, leaving the inside alone, times the derivative of the inside. Well, here, if that's true, then f of g of x, let's write that out, see what it looks like, is going to be the f function, except the x in the f function is now going to be replaced with the g expression. So it will be 3 times, let's input the g expression, natural log of x plus x, all raised to the fifth power. And to find our derivative, we will apply our derivative rule. So the derivative with respect to x of f of g of x, we take the derivative of the outside operation, which is our fifth power. So we'll use the power rule, bring down the 5, and 3 times 5 is going to be 15. Leave the inside alone, natural log of x plus x, raised to the fourth power now because of our power rule. And then we multiply by the derivative of the inside, the g prime. And g prime is going to be the derivative of the natural log of x, which is 1 over x, plus the derivative of x, which is 1. And there we have our derivative. The derivative of the outside, leave the inside alone, times the derivative of the inside. Okay, let's look at one more example. Okay, here we get an opportunity to see how the chain rule can be applied multiple times. We have multiple layers going on with this composite function. Here, f of x is the sine of the square root of x minus e to the x squared, all raised to the fourth power. So in my mind, I think about, well, what's my outside operation? That's going to be, once I've calculated everything inside the parentheses, I raise it to the fourth power. So that is my outside operation. Inside, I have the sine minus e to a power. So the next thing I would do is take the derivative of my sine and e, leaving those things that I am using with the sine and e alone, and then finally multiplying by that final operation, the square root of x or x squared, those derivatives. Here's what I mean. Let's start by taking the derivative of the outside operation, which is raising to the fourth power. I'm raising something to the fourth power. So that would mean that I bring down the 4, leave the inside alone. So sine of the square root of x minus e to the x squared. All of that is now raised to the third power because of the power rule. Then I multiply by the derivative of the inside. So the derivative of the sine of square root of x, that's also a composite function where sine is the outside operation and the square root of x is the inside. So with the chain rule for that, I take the derivative of the outside. The derivative of sine is cosine. Leave the inside alone, square root of x, and then I multiply by the derivative of the inside, where the square root of x is really x to the 1/2. And the derivative of x to the 1/2 is 1/2 x to the minus 1/2. So that's the derivative of the first term inside the parentheses. For the derivative of the second term, I have the derivative of e to the x squared. Well, as we discussed in the first video, the inside function is x squared, and the outside is the exponential. So the derivative of e to the x is just e to the x. So I'm going to take the derivative of e to the x squared and get e to the x squared. But now I have to multiply by the derivative of my exponent. So times 2x. And that would be the derivative of the inside of my original function that was being raised to the fourth power. So the chain rule can be applied multiple times because we can create a composite function with multiple layers. All right, that's the end of my examples for topic 3.1.